All right, had somebody else ask me about some 3D lines, and we're trying to show that three lines are not concurrent, meaning they don't all intersect at the same point. So we have three different equations of lines, all written in this wonderful form where they're kind of three-headed equations. Let's see if I can fit this on here. I'm going to try to fit all three of them side by side. X plus 3 over 4, y plus 1, 3 minus z over 2, L3, x minus 1 over 3 equals negative y over 2 equals z minus 2. Great. Okay. So we're going to use a different parameter for each of them, and we're going to parameterize all the equations. We'll get a big system of equations. We'll do a lot of algebra, and eventually something's going to go wrong because it asks us to show that they're not concurrent. So the point is that you try to manipulate this so you can use your system of equation skills on it. So I'm going to use t for the first line, lambda for the second line, and mu for the third line. You can use whatever parameters you want as long as they're not already being used in the problem. So if all of these are equal to t, that means that x is equal to 2t minus 5, y is equal to t minus 3, z is equal to 5 minus t. If 5 minus z equals t, then you can add z and subtract t. The second line, we're going to use a different parameter. Let's just use lambda, like I said. So x equals 4 lambda minus 3, y lambda minus 1, z 2 lambda, oh, the dang negative, how does that work? So 2 lambda equals 3 minus z, so 3 minus 2 lambda, or negative, I can go like this, 3 minus 2 lambda. Because if you multiply by 2, add z, subtract 2 lambda. Okay, and then L3, x equals 3 mu plus 1, y equals negative 2 mu, z equals mu plus 2. Did I do that right? That looks good to me. Okay, so now we have multiple equations for x, for y, and for z. So we're going to try to smash them together and use some system of equation skills. So let's start with the red and the purple. So I'm going to say that my x value from red is equal to my x value from purple. That will obtain, if I add 5, I will have 2t equals 4 lambda plus 2. T equals 2 lambda plus 1. Great. Now, let's set the next ones equal to each other. Red equals purple. Add 3. T equals lambda plus 2. Substitute what we just found for t. 2 lambda plus 1 equals lambda plus 2. Subtract lambda, subtract 1. Lambda equals 1. Let's just go back over here. T is equal to 2 times lambda plus 1. So t equals 3. Wonderful. So that means that line 1 and line 2 cross over each other. Line 1 and line 2 cross over each other when t equals 3 and lambda equals 1. And that's the only place that they cross over each other. And so that means that we can now figure out what the x and the y and the z values are as well. So we know in our red equations that x equals 6 minus 5, that y equals 3 minus 3, and that z equals 5 minus 3. So unless I made a mistake, we have x equals 1, y equals 0, and z equals 2. Let's check it with the purple zone. We're saying lambda equals 1. So x equals 4 minus 3, y equals 1 minus 1, z equals 3 minus 2. So x equals 1, y equals 0, z equals negative 1. Uh-oh. That's interesting. What went wrong? Well, we found that when we set the x values together and we set the y values together, that we could do that if t equals 3 and if lambda equals 1. I don't think I made any mistakes there. I set 2t minus 5, t minus 3. Did I copy it down wrong? Nope. 4 lambda minus 3, lambda minus 1. That's pretty straightforward. And after I found the t value, I substituted that incorrectly. I divided by 2 correctly. Great. I'm just double checking because if you copy something down wrong, then everything else goes haywire. So what we just found actually is enough to answer the question, which is just that L1 and L2 don't intersect. The only way that lines can intersect is if their x values equal, their y values equal, and their z values equal. When we forced the x values to equal, we knew that t had to be 2 lambda plus 1. When we forced the y values to equal, we knew that t had to equal lambda plus 2. From that, we knew that t equals 3 and lambda equals 1, which gave us coordinates for x, y, and z. So the L1 and L2 don't intersect. So the third line is actually superfluous here. So yeah, I don't think I really want to say anything else about this problem. We could have done L1 equals L3. There's no reason to start with L1 equals L2. We could have started by equating the z coordinates to it. And we would have run into some other sort of contradiction at some point if we had started with setting, say, let's just say we had set this z value equal to this z value to get started, or if we had set it equal to this z value, we would have run into a problem somewhere. We just ran into it a little earlier than I expected when I started making the video. But such is life. Sometimes you get lucky. So, not concurrent. Let me know if you got questions.